Hi everyone, welcome back to another video on qualitative analysis. In this video, we'll be learning about tests for anions. There will be a few questions posed in this video that I will need you to think about and discuss them with your chemistry teacher. The anions that are covered in this syllabus are nitrate ion, chloride ion, carbonate ion, and sulfate ion. In your notes, you will see the table of anions and their tests. You will also see a column that describes the observations and also the chemistry behind the tests. The first anion we see here is the carbonate ion. To test for carbonate ion, we add an acid. Usually, hydrochloric or nitric acid is used as they mostly form soluble salts. Question: why is it necessary to ensure that a soluble salt is produced? Do think about this and discuss your answers with your teachers. So let's go back to the notes. As we have learned in the topics acids, carbonate will react with acids to form carbon dioxide, salt, and water, which we can derive from the acronym CaSWC, or some of you may call it as Keswick. The carbon dioxide produced can be seen as effervescence, but how do we confirm that the effervescence was caused by carbon dioxide? That's right. You can test for the presence of carbon dioxide by bubbling the gas produced through lime water. The carbon dioxide will then form a white precipitate in lime water according to this equation. So as you can see, the effervescence is caused by carbon dioxide and the white precipitate is caused by the formation of calcium carbonate. For the next two ions, sulfates and chlorides, we will revisit precipitation and insoluble salts. So if you can recall the insoluble salt rep, silver lead chloride, barium calcium lead sulfate. Okay, I'm no Nicki Minaj, so I'm not going to rap for you. Alright, so based on this rep, you will see that silver chloride, lead 2 chloride, barium sulfate, calcium sulfate, and lead 2 sulfates are your insoluble salts. So for the test of sulfate ion and chloride ions, we want to form the insoluble salts as evidence of their presence. So in the case of sulfate ion, we will want to form barium sulfate, okay, which will be seen as a white precipitate. So this white precipitate is actually your barium sulfate. In order to do this, in order to form the white precipitate, we add a soluble barium salt, okay, which is either your barium nitrate or barium chloride, to the unknown sulfate ion. We will also add acid to confirm that the white precipitate form is barium sulfate. Now, why do we add the acid? This will be explained further in slide 36. So for the example in the video, I added barium nitrate to an unknown sodium salt. So when I add it, you can see that the white precipitate is formed. As the white precipitate seen is barium sulfate, it means that the sodium salt must contain a sulfate, which you can see in this equation. In the case of chloride ion, we will want to form silver chloride, which can be seen as a white precipitate also. In order to do this, we add a soluble silver salt, usually is silver nitrate, to the soluble chloride ion. We will also add acid to confirm that the white precipitate form is silver chloride. So for the example in the video, I added silver nitrate to an unknown sodium salt. So you can see that the white precipitate is formed, and we know that the white precipitate is silver chloride. So it means that the sodium salt must contain a chloride, as you can see in this equation. It's not enough for you to know the chemistry behind it, you also need to know how to write ionic equations for the formation of barium sulfate and silver chloride. So I'm just going to show you a simple way on how to construct this ionic equation. It's really very simple. So I will use the precipitation of silver chloride as an example. So first, you write down the formula of silver chloride with state symbol on the right hand side of the equation. So this is my right hand side, so which is usually your product. As silver chloride is a white precipitate, your state will be solid. Secondly, we will write down the ions that make up silver chloride on the left hand side. So this is my left hand side. Okay, so it's silver Ag plus and Cl minus. Please remember that the silver ion is Ag plus. Lastly, we write the state symbols on the left hand side. Since your silver and chloride are in solution, they should be aqueous state. because this is from your silver nitrate and this is from your unknown chloride salt, and this is your white precipitate. Okay, so now try it for barium sulfate. So this is the ionic equation for your barium sulfate. Were you able to get this? So the last anion that we'll be testing for is your nitrate ion. What do you notice about the test for nitrate ion? You got it. It is very similar to the test of ammonium ion. So let's highlight the similarities between the two tests. So the similarities are your sodium hydroxide, warming, and ammonia gas is produced. What is the only difference between the two tests? So I'm going to use a different colored highlighter for you to see the difference. So you can see that the only difference between the two tests is aluminum foil is added. Other than aluminum foil, sometimes we also use aluminum powder. Now the chemistry behind this reaction is not in syllabus, but I've already stated it inside your notes, and you can ask your chem teachers if you're really interested to know more about this. So back to the observations. Unlike the test for ammonium ion, this reaction will actually produce effervescence. This reaction is quite vigorous, so you want to be careful when you're heating it. The effervescence may cause the solution to shoot out from the test tube. So how do you confirm that the gas from the effervescence is ammonia gas? Yep, you test it with damp red litmus paper, and the litmus paper will turn blue. Be careful not to touch the test tube with your litmus paper, as you will contaminate the litmus paper and affect the results. As you can see, this slide, it summarizes the comparison between the test for ammonium ion and the nitrate ion. Let's go back to why is there need to add acid to silver nitrate and barium nitrate or barium chloride when testing for chloride and sulfates respectively. This is to confirm that the white precipitate formed is silver chloride or barium sulfate respectively. How would the acid do that? Well, before we go into that, you would need to understand that sometimes the unknown may contain carbonates. And carbonates also form mostly white precipitate with silver ion and barium ion. So you can see in this video that when I add silver nitrate and barium nitrate, precipitate is being formed. So we also learned that carbonates will react with acids. So how do I confirm that the white precipitate is a sulfate and not a carbonate? When I add nitric acid, the nitric acid will then react with the carbonate. When it reacts with the carbonate, it will remove the carbonate. So what do you see? The acid will then dissolve the precipitate if it was a carbonate, but if it was a sulfate or a chloride, the precipitate will not dissolve. That means it's insoluble in the acid. So you can see in this video, okay, that when I add acid into the solution that contains the barium sulfate and the silver chloride, you can see that the precipitate remains. And you can see that when I add the nitric acid to the silver carbonate and the barium carbonate, the precipitate dissolves and you can see effervescence being formed. Okay, that's it. That's the end of our video. So try the questions in this slide by scanning the QR code. So have fun. Bye-bye.